In this video, I will be explaining how to solve an example in which we need to find the future value of a general annuity. The example is the following. Mrs. Jagger made payment of $150 at the end of every 3 months for 16 years, earning 4.5% compounded month. How much interest is included in the future value of the annuity? So the problem is this, and we have an annuity like this. Let's represent this in a line. You don't need to draw a line to solve a problem of an annuity, but it will be a good idea if you made a line, at least in your mind. So think in a time in which you are making payment of 150 during 16 years, and you want to compute the future value of the annuity. The question is how much interest is included in the future value of the annuity. So it will be a good idea to know what is the future value of the annuity. So, and we know the formula of future value, that is, the future value is the payment, open bracket, 1 plus I to the power n minus 1 divided by I. What to do? So check for the things that are given in the problem. For example, they tell me that Mrs. Jagger has made payment of $150. So these 150 are the payments. So R equal $150. So we have also that these payments are at the end of every 3 months, so every quarter. So there are 4 payments per year. So look for how many payments per year, and there are 4 payments per year. So you know that K equal 4. I'm using K for representing the number of payments per years. Let's continue reading. This is given for 16 years. So for 16 years, so it means that the term is 16 years, so you can find n now. N equals 16 times 4, so 64. So n, remember, is always the term, the time of the annuity multiplied by the number of payment per year. Number of payment per year. Some students made the mistake and multiply by the number of compounded period. No, in a general annuity, for the number of payment per years. And the number of payment per years will be 4, so it will be 16 times 4, 64. So we have that n equals 64. This is important because the formula have n, 64. And now let's find the I, the periodic rate of interest. We know that this R is 4.5, so the nominal rate of interest is 4.5%. So this is the nominal rate of interest, and is compounded monthly, so it means that M equal 12. There are 12 conversion periods in a year, so this M is the number of conversion periods. Because I noted that K and M are different, so this is an example of a general annuity. So I is not just dividing R divided by M, no, this is in the case of a simple annuity. But now I will be using this formula, as I equal 1 plus R over M to the power M over K minus 1. M is the number of conversion periods per year, K is the number of payment per years. So you will need to use this formula to compute the periodic rate of interest that you need to put here in the formula. So this is in the case that we have a general annuity when K and M are different. So make a substitution of everything. So I make a substitution and I found this. So this is the 0.045 is the nominal rate of interest. 12 is the number of conversion periods per year. And here the number of conversion periods per year divided by the number of payment per years. So it's easy to remember these things here. Always the number of conversion periods is in the exponent is at the top. In the rate of interest is at the bottom. So put the number of conversion periods per year at the bottom here in the denominator, and here put the number of conversion periods at the numerator of the exponent. Okay, so now that you have here, just use a calculator to compute this number. I did it, and I found that this is 0.011292224. So this is the number that I'm going to put here in the formula of I. So I did it. So I used the formula of the future value of an ordinary annuity. So this is an ordinary annuity because the payments are at the end of every period. Okay, so use the formula. R This will be the future value after 64 payments. R is 150. This I is the number that we computed, and this N is this 64. So I make a substitution and use your calculator. I already used my calculator and made the computation of this, and I found that this is 13,969.79, rounded to 2 decimal places. This is the future value, but the question is how much interest is included in the future value of the annuity. This future value is actually all the payments plus the interest that was earned in every payment. This 150 is earning interest from the beginning. After the first quarter, this 150 start earning interest. This 150 have earned interest for n-1 period. So every 150 payment have earned interest. The only payment that doesn't earn interest is the last payment. So what to do to get the interest earned? So to compute the amount of interest, it will be the future value minus the contribution. And the contribution is actually the amount of payment that you have made. So Sn is the 13,969.79. The contribution was 150 contributed 64 times. So it's future value minus N times R. This N is the number of payments, these R are the payments. So the last value minus the contribution. The amount that is at the end minus the contribution. So look for that, just make a substitution. So it will be 13,969.79 minus 64, the number of payments, multiplied by 150. So when you do that, the answer is 4,369.79. So it means that this $150 with this interest during 16 years have earned this interest. Okay, and with this I finish my explanation of this problem. Thank you.